हाँ सर ने ज्वाइन कर लिया है।
हाँ नमस्कार सर।
सर नमस्ते सर, नमस्ते सर, मोस्ट वेलकम सर।
कैसे हैं सर?
सर बढ़िया, आशीर्वाद है।
सर क्या अभी लेक्चर हो रहा है कोई और?
हाँ सर चल रहे हैं अभी। अब लंच के बाद आपका है, पहला 1 से 2:30 लंच था,
हाँ
उसके बाद आपका है, फिर 1 4 से उसके बाद फिर है सर।
तो शुरू करें।
हाँ, नमस्कार
हाँ, सर
डॉक्टर
बस।
मनु प्रताप सिंह जी,
सर नमस्कार सर।
कैसे हैं?
सर बढ़िया सर बढ़िया, आप कैसे हैं सर?
बस बढ़िया। कैसा है मौसम आपके शहर में?
सर ठीक हो रहा है सर, बरसात पड़ रही है।
अच्छा अच्छा, दूर तक हो रही है।
और
चलिए,
आप
आप
ठीक है सर?
ऑफलाइन आते तो और भी अच्छा लगता है हमें।
अब सर मैं तो कहा था शर्मा जी को कि कल बता देना, कल इनका फोन ही नहीं आया तो मुझे लगा ये छुट्टी नहीं है।
सर मैं ऊपर कल
हमें लगा चाहते ही नहीं है वहां जाए।
अरे सर ऐसा बिल्कुल नहीं है।
तो
कल
घर
मैं
है।
थोड़ा सा, उस दिन मैंने सोचा बात होगी थी आपसे।
हाँ सर, कितनी ना, एक तो बरसात का भी हो रहा है मौसम, थोड़ा सा अवॉइड भी करता है आदमी निकलना तो।
जी संदीप जी शुरू करवाओ।
नमस्कार सर, मनु प्रताप सर, नमस्कार। आई एम डॉक्टर संदीप फ्रॉम द डिपार्टमेंट ऑफ मैथमेटिक्स।
जी
सर स्टार्ट करें?
हाँ हाँ, मुझे आप शेयरिंग का वो दीजिए, राइट?
ओके
Recording in progress.
मिस नीतू, यू विल स्टार्ट CV ऑफ आवर स्पीकर।
आवाज नहीं आ रही बेटा तुम्हारा, सर का इंट्रोडक्शन शुरू करो।
Good afternoon to everyone. It's my pleasure to introduce our honorable speaker. Welcome to the second session of day 2 of this 5-day international workshop on cutting-edge innovations in soft computing, communication, and artificial intelligence, which is organized by Department of Mathematics, Chaudhry Charan Singh University, in association with DRDO New Delhi. In this session, I welcome to our honorable speaker, Professor MP Singh. He is connected with us in online mode. Before we invite Dr. Manu Pratap Singh to deliver his talk, let me briefly introduce to him. Professor Manu Pratap Singh received his PhD from Kumaon University, Nainital, Uttarakhand, India in 2001. He completed his Master of Science in Computer Science from Allahabad University, Allahabad in 1995. He is currently working as professor in Department of Computer Science and Director of Institute of Engineering and Technology, Dr. B.R. Ambedkar University, Agra, UP, India since 2014. He is engaged in teaching and research since last 20 years. He has more than 90 research papers in journals of international and national repute. His work has been recognized widely around the world in the form of citation of his research papers. He also has received the Young Scientist Award in Computer Science in International Academy of Physical Science, Allahabad in year 2005. He has guided 18 students for their doctorate in computer science. He is also deputy of various international and national journals. His research interest come to you, sir.
Recording in progress.
Thank you for introducing me, and without taking much time, I would like to start my lecture, and I'm hoping that my slides are visible.
Yes sir, they are visible.
Yes sir.
Okay.
Very good.
So now, as the anchor has introduced me about my topic, and she has already informed you that my topic is pattern classification using quantum neural network, a novel approach in the machine learning. Before I enter into the entire discussion of the neural network and then take a journey from neural network to quantum computing, I will start with a very few words. My words are like that. If you see the entire scenario of computation, currently the computation which we are using, that computation is supporting the irreversible process of computing. It means that if we have the logic gates and if I apply any input on it, I obtain the output, but that process cannot apply in a reverse manner. It means that it cannot happen if I apply the output as an input and I will add the same input. It means that the computation which we have is only in a one direction. It means that the information flow in a computer is only from the input to output. The the reversible thing will not happen. Now, the age of nowadays is indicating the new scenario of computation where we have the information which is available to us, and that information is artificially intelligent. The issue is that how to use that information in appropriate way, because the information is quite large. It is smart information. That smart information has to be used for the various work. Most important work which we have and now in the society is that how to extract the useful information and use it for our applications. In this way, I will just start with a few lines here, and my lines are as follows. My first question is that which type of the computations we have and which type of the computation we had, and now which type of computation we require. So initially, when computer was invented, at the time it was a thought that computer can only do the numerical processing. It is being used for the calculations, and it is only handling the numbers. After the few age and in the early 1960, it is being realized and concept has been introduced that if a computer is able to do the numerical processing, why not the computer can do the symbolic processing? It means that the computer should also able to handle the symbols, manipulate the symbols, and derive an inference by using the symbols. That symbolic processing opens the door for the artificial intelligence. So now we have a change in the paradigm, or a paradigm shift is there. That paradigm shift was indicating that we have started from the numerical processing and leads for the symbolic processing, which opened the door for the artificial intelligence. Another type of the computation which we encountered here is the hard computing versus the soft computing. The hard computing indicates that if we have the deterministic approach for solving the problem, and when we have the certain outcome of any problem, then we are using the hard computing approach. But on the other hand, if we have such type of the problems, and these problems are like that where we have the uncertainty in the outcome due to the vagueness, imprecision, incomplete, partial truth, partial false information, then which type of computation we required? And the answer was that we required the soft computing. We have the another type of computation, and that computation was indicating that we have the additional computing, and on the other hand, we have the machine learning computing. Now, if you just see that in the additional computing, we have the input, we have the explicit computer program. When computer program is in a computer, the input data is presented and computer is able to generate the output. The machine learning computation has changed the scenario. Machine learning says that we don't require any explicit computer program. We have the input data, we have the output information, past input, past output, or we have the historical information about the input and the output. When the input output data is presented, computer should able to generate the implicit mapping function which exists between input and output, and it is changing the computation that we don't require any explicit computer program. After that, we have the another type of the computation, and that computation indicates that we have the neural networks of cognitive type computation, and if we introduce more deeper insight, we have the deep learning computing. It means to say that in the neural networks computing, we have to first extract the feature by hand by using the reprocessing techniques. And after extracting the feature, these feature pattern vectors are presented to the neural network, and we are performing the task of the pattern recognition. But the deep learning computing has changed the scenario. We don't need or we don't require any hand drafted features. The deep learning architecture, due to its deeper architecture of hidden layers, it is itself able to find the features, and these features are mapped further, and we have the classification and the recognition. Another computation which we have is the binary computing and the fuzzy computing. As you all aware that in the binary computing we have the either 1 or 0, but fuzzy computing says we have the many values or infinite values in between the 0 and 1. Now it is a point which we have to understand the reversible versus non-reversible computing. The additional computing, the hard computing and soft computing, machine learning and all the deep learning, neural network, all these computing are following the non-reversible computing, and quantum computing is following the concept of the reversible computing. It means the quantum computing indicates if we have the input and we are finding the output, and if we reverse the thing, then the same scenario we can regenerate. In this sense, we have the computation with the bits as we were doing in the additional computing, and in the quantum computing we have the qubits. And on the other hand, we have the logic gates; those are handling the binary digits. And on the other hand, we have the quantum gates computing, which is handling the qubits. So now the discussion indicates how we can take a shift from the machine learning computing, which is the totally irreversible, non-reversible, to the reversible computing by using the qubit and the quantum gate computing, and now try to build an algorithm. That algorithm is a quantum machine learning algorithm. So it is the focus of the talk which I have to explain here. Now we have the three methods for solving the problems. As I have mentioned already, first is the hard computing, second is the soft computing, and third is the quantum computing. The hard computing is handling the deterministic models. On the other hand, the soft computing is handling the uncertainty, randomization, and it is using the statistical methods for handling or for solving the problems. On the other hand, quantum computation is handling the uncertainty, and it is handling the real world quantum system and using the decoherence, and it is the elastic with the quantum mechanics or quantum operations. So first let me start with the how the things have changed from additional computing to the machine learning computing. As I have already explained to you, in the additional computer programming we require the input data, we require the explicit computer program. Computer use that program, data is presented as input, and computer is generating the output. And on the other hand, in the machine learning, we don't require any explicit computer program. We have the input data, we have the output information, and computer is generating the implicit functional mapping in between input and output. So now it is a change how the machine learning has changed the programming concept. So it means that rather than using a deterministic approach for solving the problem, we can find the solution of the problem by using the previous historical data or information which is reliable and available. It is a simple mechanism which we are following for the machine learning, and it is simply indicating to you that we have the input samples. These input samples are available in the form of the training sets. So that training set is containing the input pattern vectors, or it may happen that it is containing the input output pattern vectors. These input output pattern vectors are presented to the computer machine, and that computer machine is using some training algorithm, some training system, and it learns the pattern information, and from this learning it is able to find the solution of the problem in terms of the recognition. And when the machine has been trained or it has been learned, we validate the performance. So for it we use the testing of it. For it we use the test pattern set, and test pattern set are presented, and if the behavior of the computer machine is resembling with the behavior which we obtained during the training, the same behavior is appearing in the testing phase, only then we can say the computer is able to learn, or it has learned the information was available in the training set. Now, it is the journey which we have started from the neural network. It is a layer type of the architecture. We have the input layer, hidden layers, and the output layers. And in this architecture, we are using this type of the neural network approach for the training and learning and for recalling. And it is being used for the various applications of pattern recognition. Now, from here, we have a change that first initially when the AI has started, we have the rule-based system in which we have the input, we have the hand-designed computer program, and we were finding the output. After that, we have the classical machine learning approach in which we have the input. As I have already told you, we are finding the hand-designed features, and these features are presented to the neural network. And from there, we are finding the mapping from features and we are getting the output, and that output is used for the pattern recognition. Now, the deep learning approach has changed the scenario. We don't require any hand designed features. We only have the input pattern, and these are being used as sample features and additional extra layers or hidden layers of the deep neural network architecture itself extracting the features. Then the features are mapped and we were getting the outputs. Now it is the related discipline with the machine learning. So it is not a single area. It is not a single subject. It is involving so many disciplines. Now you can see it is involving the AI, decision theory, control theory, game theory, philosophy, psychology, optimization, data mining, statistical approach, biological evolution, and so many other approaches. Now, from here, we can see that if the machine learning in itself, using the so many disciplines for exploration or for finding the algorithms or for generating the answers or for using in the various applications, why not the principles of quantum mechanics can be used with the approach of machine learning. So now we take a change from here that we are moving from the machine learning approach or additional computing approach or irreversible computing approach to the quantum computing approach. So now here we are. So now first, we just try to understand what exactly is the meaning of quantum computing and in which way the quantum computing is supposed to work. So it is a new model of computing, and that model of computing is following the principles of quantum mechanics. It means it follows the principle of uncertainties. It follows the principle of superposition of states. It follows the principle of linear transformation. It follows the principle of measurements. It follows the principle of difference. It follows the principle of coherence and so many other principles of the quantum mechanics. It includes the quantum circuits, and of course, as we have the Turing machine for the computer, we also have the quantum Turing machine to find out the complexity and the earth of the quantum algorithms, and it is more powerful than conventional computation approaches. So now we can understand that quantum computer is what? It is a computer which uses the quantum mechanical phenomena to perform operation on data through the two approaches. One approach is the superposition of the states and second approach is the entanglement. So now the two things are important to implement the quantum computing approach. The first is the superposition of the state. That how we are able to represent quantum state. It is the superposition of the state. It means that in a conventional computing, we have either 1 or 0. But in quantum computing, we may have 1, we may have 0, and we may have 0 and 1 both at the same time. So it is the superposition of the states. And it also follows the entanglement. It means the state both are stable, and if the states are stable, only then we can use it. Now, obviously, in a classical computer, a computer uses the voltages through the circuits and gates, and it is being used and it is being simply follow the classical mechanics. It is a comparison which we have in between the quantum computing and classical computing. So now you can just see the classical computing calculates with transistors and which can be represented with either 0 or either 1. Now here you can see the quantum computing calculate the qubits, and the qubits can be represented 0 and 1 at the same time. It is a very interesting phenomena of the quantum computing that we have the superposition of the states. Here you can see that power increases in a one-to-one relationship with number of transistors. As you increase the hardware, the power will increase. But here you can see as you increase the qubits, the power is of computation is increasing exponentially. So it means that it is a more powerful computation with respect to classical computing. Now, you can also see that most everyday processing is best handled by the classical computers, is obviously, but the complicated tasks like the optimization, data analysis, and simulation, these type of tasks can be well performed by the quantum computing. Further, as I already explained to you, the simple classical bit means 0 or 1. It means equivalent to switching of light as a on and off. Answer is yes or no. Whereas if the qubit is 1 and oblique or 1, it means it can be both at the same time. So it is being explored by the superposition of state, and which makes the quantum computing fundamentally different from your classical computer. So now it is the way that we can represent the states. So now this is the electron, it is the spin of the electron, so it is being represented with the state 1. It is a spin of an electron which I am representing with the state 0. Actually, it is a state, and in a linear algebra, we consider these states as the computational basis. So we have a vector space. In the vector space, we have a span, and from the span, we are computing or we are finding the basis, and from the computational purpose, we are using the computational basis, and computational bases are 0 and 1, and they are orthogonal. So now with this orthogonality in a Hilbert space, we are representing the states of quantum bits. So it is being as a 1 as a 0. It is a operator, at operator. This is the at operator which is being used by the Heisenberg to express the quantum mechanics. The same operators we are using here to express the state. Actually, these operators, you can understand that that state is actually a vector. So it means that the state, you can resemble the state with a vector in a space. Here we are painting with the 0, 1, 0, 1. The state is 0, 1, 0, 1 state vector. So it is being equivalent to 5. Here we have the 4 plus 5 both. It is the superposition of the states. The quantum mechanics can be understood, or the quantum computing can be understood in a better way if we have the idea of linear algebra. Linear algebra is a way to express quantum computing operators and how to represent the things in a machine. All the things are available, or it can be exported from the linear algebra. So as per the linear algebra concept, the operation which we are applying on a qubits, all these operations are unitary operators. It means that the operators or the quantum operators, those will apply on the qubit. All the operators are the unitary operator. So now the quantum computing supports the unitary transformations. Third point is the measurement. So now here we have a one point which we can think that if I am saying that the state means the superposition of the states, either 1 or 0, then how the things will be observed in the real world. The output or the real world output cannot work on the uncertainty. So now to handle such uncertainty, we are using the measurement in a quantum computing. So now here you can see that we have the quantum state, the qubit. Here we have a measurement device, and that measurement is converting the quantum state into the classical bit. It means the answer which we are finding will be either 1 or 0. So it means that what is happening when the quantum system remain in a quantum phenomena. It means when quantum system is not interacting with the environment or outside world, it remains in a superposition of the states. And as soon as the quantum system interacts with the environment, the system collapses. And we call it as the deep coherence. And in the deep coherence process means when quantum system is deep coherence, it means it is interacting with the environment. And when it is interacting with the environment, the quantum system collapses. When it collapses, it settles on a state, and on which state it settles, it is the output state. So in this way, we are able to implement the things. Now it is the way that how we are representing the quantum bit. So now you can see that it is a two-dimensional vector of unit length 1, and it is being expressed in this way. Now, so it is a basis states 0 and 1, and we are expressing quantum states by the alpha computational basis 0 plus beta computational basis 1, and it is a complex space. So now it is a two-dimensional complex space where alpha and beta are the complex numbers, and you can see that it is representing, alpha is representing the probability of finding the state on the 0, beta is expressing the probability of finding the state at 1, and probability alpha is mod of alpha square plus this is equals to 1. So in this way, the qubit is expressed. Now, to present into the matrix form, as I have already told you that we are taking the help from the linear algebra for expression or for expressing the quantum computing from the computational point of view. So now we are expressing the state. That state is being represented as a psi. It is the operator cat is used. It is alpha plus state 0 plus beta plus 1, and I already explained to you. So now we can represent that state as a matrix form or vector form alpha and beta. Now if we have the two qubits, it is about the single qubit. Now if we have the two qubits, so now we have the state is alpha 1, alpha 2, alpha 3, alpha 4, and we can express all these in a vector form. Alpha 1, it is showing the highest probability of finding the state 0, 0. It is showing probability of finding the state 0, 1, and alpha 3 is showing the probability of finding the state 0, and alpha 4 is showing the probability of finding the state 1, 1. It is the way how we are representing the psi. It is the psi, and now you can see that x and y, 0 and 1 are both having the equal probability. Here also at the state x, the 0 and 1 both have the equal probability that it may happen 0, it may happen 1. It is the way of expressing the 0 bit or 0 state or state 1 in a qubit system. 0 I will express in a vector form 1, 0. It is a column vector. 1 and 0 is used to represent the 0 from the computational point of view. 1 I will express as a 0, 1. And for the 2 qubit, 0 means 0, 0, which is state, and the state is expressed as a 1, 0, 0, 0. It means that alpha 1 is 1, other alpha 2, alpha 3, alpha 4 are 0. It is the 1. It is the state is 0, 1. So I will express it as a 0, 1, 0, 0. It means alpha 1 0, alpha 2 is 1, alpha 3 is 0, alpha 4 0, and so on. In this way, the 3 is expressed as a 0, 0, 1. So in this way, we are able to represent the qubits and the states are using the matrix form or the vector form. Now, the another part of the quantum computing is unitary transformation. So it means that it is a linear transformation that preserves the vector form in a two-dimensional linear transformation that preserves the unit circle. It means the rotation and the reflections. It is the examples of some operators. Now you can see that either we can change the bits or we can use the Helmholtz transform. It is the way that how the zero computational basis is changing into one and one in the zero. It is another operator that after applying the operator or Helmholtz transform on the state zero, I can find the state this. On applying the Helmholtz operator on the state one, I can find the state this. It is the now you can see the quantum aids that how I have organized the H gate means Helmholtz transformation, and now it is the C not 8, and all these are arranged in a way that I can find this circuit path. So quantum or the aids acts on the n qubits. It is the 2 raised to n 2 raised to n unitary transformation. It means that all these conditions are satisfying, only then we can say it is the unitary operator. Right. So now it is the some common aids which we are using in a quantum computing. The fundamental aid is the C0 gate. So now you can see that what is expressed in this way, 0, it is 1. The C0 is expressed by this expression, and it is the table of the C0 gate and control E gate and control V plus gate. So all these are the operators of quantum aid those we are using for the application, and it is the H gate which I have already explained to you. Now we are also using some more quantum operators, and these are being recognized as the Poly gates, X gate, Y gate, Z gate, and obviously the H gate. This is the X gate, it is the Y gate, Z gate, and H gate. All these are being applying on a 1 qubits. All the gates, X gate, Y gate, Z gate, and H gates are applying on a 1 qubit. So after applying these operators on a 1 qubit, it means that if I apply on a 0, X into 0 state, then it means that this X matrix will multiply with the 0 vector means 1 and 0, and I can find the output. In a similar way, if I apply the H8 on the state 1, so I will apply H means this matrix and 1 means 0 and 1, and I can find the output state. Now, the third part is about the measurement. Now, when quantum system is interacting with the environment, then on which state it will collapse, it indicates the measurement of the quantum system and the terms of its output. So it means that we are measuring alpha 0 plus beta 1 in basis of 0 and 1, and it is indicating 0 with the probability alpha square, and this I already explained to you. And measurement change the state, it will be either 1 or 0 after the measurement. It is the way to express you the measurement. It is the state which is at present 0 and 1 both are having the equal probability. Right after that, we can find the measurement. It has to settle onto a one state. MATLAB has the facility to you that you can use the quantum computing function library QCF, which is already available in the MATLAB for the implementation of quantum computing. So I have some of the operations for you, so I can show you. We can represent the 3 qubit space, the 3 in this way. It is already inbuilt in a MATLAB. So I have to just write phi equals to binary to vector and binary, it will automatically change the binary to vector and represent the things in this way. So now here I am taking the last part of my presentation, that how we can use the quantum computing for the implementation of the neural network part. So here we are trying to elaborate you the classical neural network is existing. Now, if we replace this classical neural network system and its phenomena, its principle, its operation with the quantum operation, then what the changes we can obtain. So here we have just tried that approach with a very elementary of neural network architecture. It is the perceptron. It is a single layer neural network architecture, and classical perceptron simply uses the input layer, the output layer, and here the inputs, here the weights, and here we are finding the output. So, and we can find the output with the function f. Here f is the step up function, and it is the weight, it is the input, it is the bias or threshold. It is a very fundamental equation of the perceptron. Now we have changed the perceptron architecture by using the quantum computing operations. So first I am applying the states, x1 state and the x2 state. Here I apply the h gates. So that h8 will apply on a 1 qubit. So it is the 1 qubit. It is also 1 qubit. The h operator applying on the x1. So here we have the hx1. The h operator apply on the x2. Here we have the hx2. Here we are taking a answer product in between the h1, x1 and the x2, and here we are finding the entanglement. So here we obtain x state. That x state is a entanglement of the hx1 and the hx2. And again, this output and this outputs are applying on the h gate, and from here we have obtained h into x, and here we are finding the output. So now if we replace this architecture with classical perceptron as a quantum perceptron, we obtain the result on it, and we generate an algorithm which is a quantum perceptron learning algorithm, which I am showing to you. It is the algorithm. First, I obtain the output state by using the weight and the xj, and here other than using the hard limiting function, I use the linear function. So now at the time t, the state will be obtaining by using the weight and the input state, and here we are updating the weight in a similar way as we have obtained the weight change by using the perceptron algorithm, but instead of using the crisp output, here we are using the state vector. So now by using the quantum states, the error is obtained, and we are multiplying with the state, and we are finding the output state. So now the h8 is applying obviously. So now we have obtained the x here by using the entanglement, and here we have the h, and it is the equation which we are following here. So rather than updating the weight of the classical perceptron algorithm, here we are updating our operator. So now here we have the change. In a classical neural network learning algorithms, the algorithm says that we have to update the weights. But in a quantum computing, for the quantum neural network, so rather than updating the weights, we are updating the operator which we have or which we obtain by the entanglement. So now here the entanglement operator is updating, and from this updating the patterns are being learned. And now it is the way of finding the output that you can see that the state I am finding with the h operator, hx1 answer, and hx2. And now we apply that quantum perceptron on the XOR problem, and that XOR problem has been considered earlier as the linearly non-separable problem, and that problem cannot be solved by the perceptron. But here we found that the XOR problem has been solved by simply using the quantum synchrotron algorithm. So that is the achievement which we obtain by using the quantum computing. We obtain the result of those problems which have not been solved earlier by using the simple synchrotron. It is the final operator which we have obtained after the updating. So now it is a conclusion that we have exhibited the 2-qubit system synchrotron, and in future that idea can be extended, and we are hoping that we will able to implement the algorithm for the multi-layer architecture also. So it is all about, it is the references, and it is just a comment for you that if the AI and quantum computing is used so much, then it may happen. It's okay. So now it is the papers those we have, and thank you. So now you may ask questions if you have. If you have any query, then you can ask me.
Yes, participants, if you have any
Professor
query,
HSG.
please, you may ask.
हाँ बोलिए बोलिए प्रोफेसर एचएन सिंह जी बोलिए.
Yes, sir.
Sir,
Sir, very nice lecture. My one query is when a quantum dot interacts with quantum dot,
okay.
what are the possibilities?
Sir, quantum dot and quantum dot both are following the quantum mechanics. So
Right, sir.
it is following the superpositions. So until it will not interact with the environment, the things will not change.
Right. So, sir, we can quantify environment also, or environment may be anything.
Environment means that if we are finding the output for the outside world, only then the quantum system has to interact with the environment.
Also, if there is any output,
Yes.
then only we say the interaction is there. Right. Sir, one more thing. When we say entanglement,
Yeah.
so what aspects it includes?
Actually, the quantum state though cannot be break into the smaller state is called the entanglement
That is the ultimate state.
states.
Right.
The states those have been returned with the help of other state, and these cannot be decomposed into the smaller states.
Right. Right. Thank you so much, sir. Thank you, sir.
Good afternoon, sir. Myself Tushar from this university only, CCC University. Sir,
Yes,
yes, sir. Sir, my first question is, we're talking about the quantum computing. So, as we know that कि quantum computing से क्या होता है कि हमारा जो speed है वो increase हो जाता है because
बहुत ज्यादा increase हो जाता है.
yes sir. तो sir उसमें ये possibility भी तो हो सकती है कि बहुत unintended results हमको मिल जाएं अगर हम उसको AI के साथ
मैंने आपको ये कहा कि अब देखिए क्वांटम सिस्टम जो है वो आपको ये बता रहा है कि अगर माना आपके पास 1 बिलियन एंट्री है, ठीक है, और आपको उसमें से एक इंफॉर्मेशन निकालनी है, अगर आप क्लासिकल कंप्यूटिंग की सर्च लगाओगे तो इट विल टेक आवर एंड 2 hours, बट इफ यू अप्लाई द क्वांटम सर्च इट कैन फाइंड द आंसर इन ए 1/2 सेकंड. तो स्पीड तो इतनी फास्ट है. अब अगला जो आपका सवाल था कि if the quantum concepts are embedded into the AI, right?
Yes, sir.
Yes.
AI means what? You are trying to make computer machine intelligent, right? And quantum saying that the so many informations are collected. So obviously a machine which has a brain and it is collecting so much information. So now you can imagine how that machine should be.
ओके सर, सो मतलब हम इस जो जैसे अगर हमारे पास बहुत सारे अनइंटेंडेड रिजल्ट्स आ रहे हैं, तो कुछ ऐसा प्रोसीजर है कि हम उसको मिनिमाइज कर सकें?
Is AI minimizing? आजकल जो AI हो रही है वो भी बहुत ज्यादा एक्सप्लोर हो रही है, तो क्या उसको रोका आप लोगों ने?
काफी हद तक।
नहीं रोका। एकदम नहीं रोका। We everything we have changed into the AI. स्मार्टफोन, स्मार्ट हाउस, स्मार्ट ऑफिस, स्मार्ट फूड। तो जब वहां नहीं रुका तो फिर यहाँ कैसे रुकेगा? अब मैं आपको एक एग्जांपल बताता हूँ। आपको याद है एक पिक्चर आई थी, टर्मिनेटर?
जी सर, जी सर,
आई थी ना?
जी सर।
उसमें जो दिखाया था वो शायद रिपीट ना हो जाए रियल वर्ल्ड में।
मे बी हो सकता है सर।
हाँ, बस ये बात अल्टीमेट आंसर मैं ये कर सकता हूँ आपको।
ओके सर, थैंक यू।
Thank you, sir.
Anyone, thank you, Tushar. Anyone participant, if you have any query, please. Okay,
ओके सर।
okay. So, thank you very much, sir, for your mesmerizing talk. Yes,
Excuse me, sir, there is one more person who
Okay.
wants to ask question.
yes, please continue.
Good afternoon to all. My name is Jyoti Pundi, Research Scholar, Department of Education, CCS University, Meerut.
जी बताइए।
I belong to Education Department.
अच्छा,
And
अरे
yes, sir. And my work on AI utilization for teacher educators.
ओके।
So my question is, how can quantum computing is useful for teacher and teacher educators, which are belongs to any level of the teaching, which is primary, secondary, higher secondary, or higher education.
ओके
Thank you, sir.
madam, the things is that if you have quantum computer things, the device size will be so small. It may be fit in your finger, and in your finger like a ring, you can have all the information. मतलब अभी आप क्या है कि लैपटॉप आते हो लेके, टैबलेट आते हो लेके पढ़ाने के लिए, अगर क्वांटम अप्लाई हो गया तो ये सब चीजें हट जाएंगी। आपकी उंगली में जो अंगूठी होती है उसी अंगूठी में सब कुछ होगा। तो यू कैन इमेजिन दैट हाउ फ्रूटफुल एंड हाउ यूजफुल these things for the teaching for the students.
Okay, sir.
Anyone query if you have participants? Okay, so we conclude this talk. So, sir, we are very thankful for sharing your views in this talk. So, on the behalf of the Department of Mathematics, we convey a sincere thanks to you for this talk, and I invite to Ms. Deepthi for delivering your vote of thanks. Ms. Deepthi.
Thank you, sir. Good afternoon, all of you. On the behalf of organizing committee, I, Dipti Singh, extend my grateful gratitude to our distinguished speaker, Professor MP Singh sir, for sharing their invaluable insights and expertise with us. Your enlightening talk on the topic pattern classification using quantum machine learning, a novel approach in machine learning, has indeed broadened our horizon and provide us with new perspectives. Your patience and dedication in the field of soft computing like quantum machine learning are truly inspiring. We appreciate your time and effort to deliver such a wonderful talk. Thank you so much, sir.
Professor MP Singh ji is very known to us, and he is affiliated to us with a very long time. When I was studying, I was doing PhD. Professor Singh was very frequent to come to the department with Professor Divakar Pandey ji.
Yes.
So we are very fortunate to have such a nice person among us. So I am very thankful to you, sir, for giving us your precious time for delivering your insightful talk.
Sir, thank you very much for inviting me. Thank you
so much. Thank you. So Dear participants, we will back after half an hour, 30 minutes. So you want to discuss anything, you may discuss and take a tea, and then at 4 p.m. we will start the next session. Thank you. Thank you all.
Recording stopped.
Hello. It's going on fine. So actually, I am joining, but
ठीक है ठीक है
uh, I'm joining one thing. Just okay, and then one screen is okay. Screen is share or not? Okay, so please make it because there is internet problem in my office. That's why I'm taking. I'm in my personal quarters and try to share it through mobile. Okay, so, so
तैयार है तुम्हारा? आस्था चौहान, आवाज नहीं आ रही तुम्हारी?
यस सर सर आ रही है आवाज मेरी
हाँ, आपकी तो आ रही सुन आस्था की।
हेलो
हाँ हाँ, अब ठीक है बेटा, ठीक है।
ठीक।
कर दिया मैंने। हाँ?
Hello, Professor Mehti, you can share your screen. Now you have been making as co-host, so you are able to share your screen now.
Good afternoon, all of you. In this session, I welcome to our honorable speaker,
Recording in
Dr.
progress.
Ranjan Methi. He is an associate professor at the National Institute of Technology, Jamshedpur Mechanical Engineering Department. He obtained his bachelor's in production engineering from the Maulana Abul Kalam Azad University of Technology, master's and PhD from Jadavpur University. He is a life member of the Indian Society for Technical Education and the Institute of Engineers, a senior member of the Indian Institute of Industrial Engineering, a member of the International Association of Engineers Society of Industrial Engineering. He has more than 15 years of teaching and research experience. He has guided 8 doctoral and 12 master theses. He has more than 90 international journal publications, 20 book chapters, and 45 international conference publications. He has 8 Indian patents and 2 projects of DRDO and ARDV. He regularly reviews international journals of high repute belonging to different publishers like the Royal Society of Chemistry, European Ceramics Society, Elsevier, Springer, Wiley Sage, etc. His areas of interest are additive manufacturing, digital twin synthesis, and characterization of metal matrix composite through powder metallurgy, EDM surface modification through thin and film heat treatment, tribology, laser welding, application of soft computing techniques in manufacturing, manufacturing process modeling and optimization, artificial intelligence and machine learning applications in manufacturing, multi-criteria decision-making techniques. Today, Dr. S.R. Methi will talk about decision-making approaches for green and sustainable technologies. Welcome to you, sir.
Sir, my voice is coming, sir.
Yes, you are audible, Doctor.
Yes, sir. Screen is share, sir.
Screen is not shared here.
The screen is not share, na. So
Yeah.
need to share the screen. Mm,
Professor Mandal is retired. He also is there.
sir, am I audible, sir?
Yes, you are audible. Your voice.
Okay, sir. Exact. I'll share the screen. That something is going wrong. Okay. Okay. But the screen is not share. So now the screen is sharing.
Oh no, still it's not shared.
Is Sir, first open your file and then go to in Zoom share screen. So if you share entire screen, then your screen will be visible to us.
Make a slideshow. Show. Now share. Share screen. Let's start now. Zoom will start capturing everything. So now the screen is shared.
No, sir, still it is not share. I am calling you video call. Please take, then I will tell you.
Okay, sir. Actually, I've already shared the. Sir. Yes, sir. Sir. Screen on किए sir. Now it is visible, sir.
No, sir, it is not visible.
Screen is not visible. Na? Something is going wrong.
No, sir,
Actually.
you have to click on entire screen.
Sir, first open your screen, then go to in Zoom, share your entire screen, then it will be visible to us.
Now, initially, so this is Zoom, na? This is Zoom. So visible, allow visible to screen.
आ गई सर, स्क्रीन हो गई आपकी बीच में,
आ गया सर?
फिर चला गया, आ गया था फिर चला गया दोबारा, एक बार आ गया था फिर चला गया।
एक मिनट सर, इट इज कमिंग.
नो सर, स्टिल नॉट कमिंग, बीच में आया था एक बार।
Some technical problem is going on. I mean, एक मिनट, screen share. So share, screen share, start now.
आ गया सर, आ गया। अब आप अपनी फाइल कर दीजिए, खोल लीजिए फाइल, जो फाइल है ना वो।
So now it is coming.
Yeah, sir, it is coming. It is coming. It is like yeah.
It is
Yeah.
coming, sir. Okay,
okay,
thank you.
okay.
Okay, sir. Thank you.
Thank you,
So,
sir. You may start.
Good afternoon, everybody, and also thanks to the organizer to give me the opportunity to share a few informations with you. And the basic objective of in there is to share my knowledge, and also I will learn something from you also. So the basic topic is basically the decision-making approach for green and sustainable technology. So decision-making, this concept is not a new thing. When the human civilizations is started, and that particular time, basically decision-making may not be in science, but the man basically need to take decision each and every moment. And in a similar way, one of the crucial phase of product development is to choose the most suitable material that can allow product to perform its intended function for the desired life. The database of materials is growing an enormous rate due to the active involvement of scientific community in the domain of material development. Moreover, the material would be selected taking care of growing environmental and socio-cultural restriction apart from economic and technical consideration. The selection of suitable material for a new product become a challenging task nowadays. So, the main things are there. Basically, the criticality of selecting suitable material can be realized from the fact that the change in design of manufacturing of product, the amount of 10,000 times the cost involved during the conceptual design phase. Hence, it has become questionable to adapt a systematic approach suitably selecting a materials in the early design stage of the product development. A systematic and scientific makes it convenient for the design engineer to evaluate the performance of material from a large database under the influence of various and often conflicting attributes. The process will thereafter aid in providing opportunities for promising sustainability apart from profitability in the various product development organization. A systematic and scientific approach for selecting a suitable material comprising of three major components: to formulate constraint as per the functional, environmental, technical, economical, socio-cultural requirement that should be satisfied by the material, and next to develop a performance matrix to adjust the performance of the materials in accordance with the platform, in accordance with the problem under consideration, and lastly, formulation of a suitable such strategy, that is the decision making, that can be suitably identify the feasible material alternative meeting the formulated constraint and then rank them together. So this presentation is basically comprising a sequence of introduction, literature review, problem statement, motivations of the work, scope of the work overview, and conclusions. So in today's scenarios of growing environmental concern, the organization aim to develop green products that aids in meeting the sustainable development goal. One of the crucial phase of product development is to choose the most suitable material that can allow the product to perform its intended function for the desired life. The database of materials is going at an enormous rate due to the active involvement of scientific community in the domain of materials domains. So moreover, the materials should be selected taking care of the environmental and socio-cultural restriction apart from the socio and technological consideration. So as such, the selection of a suitable material for a new product become a challenging task. And the criticality of selecting a suitable material can be realized from the fact that change in design of the manufactured product amount of 10,000, that is I have mentioned, the cost involved during this conceptual design stage is also another task. Now, these are some important constituents of different multi-criteria decision-making framework, which is shown in this figure 1. So, in the today's scenarios of growing environmental concern, the organization aim to develop green product that aids in the meeting of sustainable development goals. However, this can be realized without the aid of systematic and scientific approach comprising of the aforesaid 3 critical parameters. The decision-making framework in the form of multi-criteria decision-making aids in selecting suitably materials that helps in the form of involved true green product development. A number of decision-making tools have been proposed to make it easier for the designer, engineer, or any types of quality control engineer to select suitable material for particular engineering problem and achieve the objective of a sustainable development. Now, this diagrams is basically showing a different MCDM frameworks because MCDM framework will consist of several things. Initially, basically, the alternatives are selecting, and then a number of criteria, that is the attributed, are selecting on the basis of experience or maybe basis of some screening knowledge. Then decision matrix may be formed. Then the decision matrix may be normalized. So normalization for the decision matrix may be done. The normalization means the decision matrix may be converted into an 0 to 1 value by different normalization techniques which is available in the literature also. And simultaneously, they need to find out the attributes weight, that is the criteria weight, which criteria having importance on the selection may be considered. And there are several techniques also available for finding the criteria's values and finally ranking the alternative according to some computational technologies. Now, multi-criteria decision-making tool nowadays is very popular because of the advanced computing systems which helps it easier through different coding technology. Okay, so and several normalization techniques are also available. This is the basics of literature review which we have done. That is the different ways we have used to find the literature search engine through which some literatures are strongly related to our work, some are partially related, some are not related, and some literature work is extremely related and which full text considerations will be taken into consider. This is basically the methodology adapted for literature review. Now, these are the few salient literature for this purpose which we have served. So, in the material selection domain that is already discussed. So, this is the research gap. So, the research gap is analyzed by means of literature reviews, which I have not discussed in details, but research gap, which is mentioned over here, that is basically the existence decision-making framework does not give due consideration to the risk appetite of the decision makers while providing evaluation. And different decision-making framework provides different ranking result when applied to a particular decision-making problem. That is the main drawbacks of the MCDM technology. MCDM techniques actually, because MCDM techniques, the ranking consistency is really poor, and few techniques having a very good ranking consistency. But when a same decision-making tool is applied for a specific problems, and another technique is applied, then there is a wide change of ranking may be taking place. This change, there are several parameters are involved for this ranking in consistency. There are several studies also considered for ranking consistency. One is basically sensitivity analysis need to conduct. And simultaneously, the fuzzy-based decision-making framework lacks a suitable aggregation mechanism to aggregate difference rating provided by the different decision makers. which maintain the flexibility, accuracy, and robustness of the decision-making framework, take care of the unbiased evaluation provided by the expert. So decision makers sometimes having biased to provide their opinions. So they should be unbiased, and there is a lacuna with regard to the accurately modeling of the linguistic performance provided by the decision maker that can closely evaluate their cognitive ability, which follows clearly normal distribution curve while providing the evaluation. The existing decision making frameworks lack to deal with the periodically associated with the data. The confidence level of the decision maker has not been considered synergically with their questionnaires consideration as such risk appetite when the evaluation, hence the decision making are made. So this is the problem statement. That is the title. That is decision making approach for green and sustainable technologies. Now, what about the motivation of the present work? So motivations means why this work is very necessary for study purpose. So what are the basic motivations of these works? Okay. So the motivation, the main motivation of this work may be commonly consider the following salient points. So the sustainable and green technologies have gained momentum worldwide because of the resource shortage, environmental pollution, and eventing the natural disaster owing to the accelerated urbanization and industrialization. So one of the key issues that was signature of the G20 summit was the promotion of the suitable practice within the global economy. One of the probable solution to promote sustainable framework is to propositions of the sustainable engineering. However, there are a number of important factors that need to be taken into consideration in order to promote sustainable engineering practices, as for instance, employability of materials that are clean and safe, minimizations of the wastage of materials, maintaining and enhancing the quality of natural ecosystem, and so on. So selection of an appropriate material in the early stage of decision and manufacturing is therefore crucial to meet the aforesaid factors, and hence truly realize the proposition of the sustainable engineering and therefore sustainable global economy. So this is the scope of the work. So prospect theory based approach for reduction of optimal reinforcement condition of agro-waste long fiber for development of the green composite materials, as well as integrated prospect theory based approach for selection of suitable lip string material for electric vehicles. Now, what are the prospect theories? So several times we are talking about basically the prospect theories, which is nowadays very popular in different decision making scenarios. So before going to the prospect theories, there are several types of tools are already applied for material selection purpose, and widely applicable tool is TOPSIS, that is technique for order performance similarity for ideal solution, Electra, Promethi, AHP, SAW, VCore, Matrix, GRA, Popras, Ivamex, PSI, NP, Mura, ODM, as well as different hybridization techniques like Fuzzy TOPSIS, Fuzzy VCore, Fuzzy ANP, Fuzzy Promethi, Fuzzy Electra is also applied. Except from this, life cycle assessment, LCA, ANN, goal programming, linear programming, utility analysis, ASBE approach, genetic algorithm has already been applied for this material selection purpose. All these techniques having different advantages as well as some disadvantages are there. So most used methodology is TOPSIS tool, which has been used individually in an integrated framework and also used for investigating the performance analysis of the other tool. The popularity of TOPSIS tool among the material and design community will be attributed to its simplistic approach. The disadvantage of TOPSIS methodology to address only quantification properties have been mitigated by the different proposed integrated framework. Next on the list of popularity are Hachi-based tool that address the qualitative properties as well as vagueness and uncertainties associated with the material data. The other popular tool as clearly mentioned that is VCore as well as analytic higher core process being dominantly used for calculation of the criteria weight and life cycle method addressing the economic and environmental aspect of associated with the material selection. The applicability of other tool, that is neural network, utility theory, goal genetic algorithm, Copras, Prometheus, Electra have also been used to address problems in material selection field, but not so prominently owing to the complexity involved in employing this tool. There have been a few recent additions of novel MCDM tool in the form of AMR, MAIRCA, DMAIC, etc. To these are basically further used to have a more transparent view in these domains. So different tools, each and every tool having some advantages as well as limitation, which will be predominantly dominated over one another. So in the present investigation, basically prospect theory based approach is widely applied. So this prospect theory based approach having some limitations as well as some techniques is also there. So this prospect theory based approach basically deals with few parameters like bio the basic methodology of this theory, if I consider, that is okay. So this is the scope one. So in the scope, you're able to find out that the methodology adapted to solve the present case study has been depicted in the figure 8, which is basically mention the different procedural steps of these methods. So this methodology adapted to solve the present case study. So the present case related to the green composite from agro waste and a very cashew nut shell oil-based bio-epoxy composite, which already we have manufactured in our lab. So Pneumata Grupena PG straw that remains after the cultivations were collected in plantation or promulgating of the variety of musket from the different part of India. The collected fresh PG straw are immersed in water for a couple of weeks. The process is known as waste wetting and facilitate the isolation of the fiber stream from the microbial degradation. So the fiber bundles were then washed under the running water, which ensure that the removal of any foreign impurities, the excess of moisture is removed from the washed fiber by drying them into a muffled furnace at 70 degrees Celsius temperature, which we have mentioned over here. So these are the basic procedural steps of this technology, which we have mentioned. So this is basically one type of bio-epoxy-based composite widely applicable for this purpose. So the bio-epoxy-based resin has been currently provided and it is purchased from the vendors, and then Cadnol is the main renewable component, and it is the building blocks and supplied by bio-epoxy-based composite. So this composite can be manufactured by means of several steps. So before going to the several steps, I'll not much more discuss regarding the manufacturing process of this composite. Before going to that, initially you need to discuss about the process of prospect theory process. These are the procedural steps. So initially formulate decision matrix, normalize the decision matrix to convert the raw data into a 0 to 1 value and obtain the criteria weight and relative weights and obtain the dominance score and obtain the dominance degree and then obtain prospective value and rank. Material can be ranked on the basis of the prospective values. Okay, so to provide the decision-making framework for green and sustainable technologies that gives due consideration to the risk appetite of the decision maker. So the attenuation factors is a very important parameters which can be represented by a theta. So the attenuation factor exhibit the gain and loss of the alternative over the other alternatives. Okay. So attenuation factors having different values. So when the attenuation factor is 0.1, means that the expert exhibit higher risk, higher risk consideration or aversions. When it is 1, denotes that the expert exhibit natural, that means the magnitude of the gains and the losses of the expert are equal with each other. When it is 2, theta is equal to 2, represent the expert exhibit risk from neutral to less, and when it is 10, means the expert do not pay too much attention to the negative impact caused by the losses. They exhibit more risk-seeking mentality. So the thing is that the primary investigation of the final material. So how the composite can be developed, the procedural step is mentioned over here. I will discuss this procedural step in such a brief manner. Initially, what will happen in the first steps of the proposed methodology, that is which I have discussed previously, what will happen? The first step of the proposed methodology, the list of criteria are identified according to which the optimal reinforcement conditions is required to be identified for the present context. And then as per the methodology, in step 2, identifications of the probable material alternative for primary investigation, then they can be listed and in the depiction of the initial list of the material alternative, the material alternative of the green composite has been fabricated by means of different ways. That can be mentioned over here. And in step 3, the probable material alternative, which is depicted previously, their properties can be characterized. So the composite samples have been prepared in accordance with the ASTM B638 standard. So the 5 samples have been prepared for each of the material alternative. So analysis of the tensile test has been carried out in ultimate tensile machines fitted, having a 1 kilonewton load cell and operating at a rate of 2 millimeter per minute. The result has been obtained by varying over a 5 test sample for each of the material alternative. A flexural stress under quasi-static conditions have been performed in accordance with the ASTM, that is American Testing Society D79010 standard, using ultimate tensile machines equipped with 1 kilonewton load cell. The test has been carried out for cross-head speed of 2 millimeter per minute. To obtain the experimental result have been discussed with the ensuing discussions. So that should be basically mentioned over here. So the tensile properties of the reinforced bioepoxy green composite have been illustrated in these figures. So it is witnessed that the tensile strength is affected favorably with the chemical treatment duration, and a reason could be attributed to the removal of some portions of the amorphous hemicellulose and non-cellulose compound as such wax and lignin. For a given fiber dissolution condition at lower fiber load level, the tensile strength of the composite has been revealed to be lower, that is 22.64% and 2.04 respectively for untreated and 1 day treated. Then that of the net bioepoxy resin for up to 1 day of chemical treatment. This could be explained through the model of Kelly and Davis, who attributed the reason for the lower failure strain of the fiber in comparison of the matrix. So as a result, the composite specimen tend to fail at a strain level correspond to the failure strain of the fiber. The premature failure is dominant at lower fiber loading and captured until a critical fiber loading conditions is reached. However, as the duration of the chemical treatment is increased up to 5 days and beyond, the tensile strain at 10% weight fiber loading enhanced slightly by 8% and 5% respectively for 5 and 10 days of chemical treatment over the net bioepoxy resin. The tensile strength increased with fiber loading of 20%, that is higher and ranging by 32% to 53% over the net bioepoxy resin, and become maximum for 30% higher and ranging by 73 to 114 over the net bioepoxy resin fiber loading. As such, 30% fiber loading suggests an optimal fiber loading condition for the tensile strength of the composite. Beyond 30% fiber loading, the tensile strength of the composite again decrease for the fiber loading 30% higher and ranging 67 to 106 over the net bioepoxy resin. So decreasing tensile strength with increasing fiber loading beyond 30% could be attributed to the to the entanglement of the fiber. Furthermore, non-uniform stress transfer taking place due to due to fiber agglomeration in the matrix at higher fiber loading and therefore may also be another reason for describing tensile strength. So this has been eliminated in the same image. Sorry, just a minute. So sorry. So meanwhile, the elastic modulus of the composite increased continuously with the incorporations of the fiber with highest correction of 40% fiber loading. The reasons of continuous enhancement of the tensile modulus can be attributed to the nature of PGF itself. The fiber with higher elastic modulus in comparison to the modulus of polymeric composite will be inhibitations of the polymeric chain movements. Now, all these figures, this figure 3.4 is basically showing the agglomerations of the high fiber loading where PGF and RAW by epoxy composite. Showing to the aforesaid region, the modulus of the composite increases continuously. Furthermore, partially spreaded microspace are created during the tensile loading and therefore obstruct the propagation of the stress beyond the fiber as well as matrix composite. Now, these are few graphical presentation of the tensile result of the composite specimens from this figure. This is the tensile strength of the PGF and green composite, which is depicted over here. And simultaneously, so these are the primary investigations from the final list of materials. So before in context of flexural strength, so these are the tensile strength results. So which we have already discussed. So these are the different variation of tensile properties of the green composite. Their elongations have been plotted with the fiber percentage constant and young modulus, which also plotted over here. These are the fractured surface which we have observed from the factography, that is scanning electron microscope. It is observed that elongation at the break with increased fiber loading. This can be attributed to the higher stiffness of PGF in comparison to the matrix material. So higher the thickness of the fiber allow lesser deformation, thereby resulting in increased brittleness of the composite material. Furthermore, lower values of elongation at break occur owing to the stiffer PGF. For a given fiber loading, the tensile strength of the composite increases with the treatment duration for up to 5 days. Beyond 5 days of the chemical treatment, the tensile strength of the composite decreases. The reasons may be attributed to the damage caused by the excessive chemical treatment on the cellular structures and orientations of the cellular fibers. This could be observed from the micrograph represent on these figures. So on the other hand, young modulus of the composite increases continuously with the duration of the chemical treatment. The reasons could be attributed to the effect of chemical treatment on young modulus of the fiber, which becomes stiffer with the durations of the chemical treatment. However, elongation at break increases because the fiber becomes softer and increase the duration of chemical treatment. Now, these are the flexural strength present. So flexural strength it basically varies. So how it can be varies? They can be mentioned that for a given conditions of the fiber resolution, the flexural properties to that of the tensile properties were exhibited by the PGF or by epoxy composite. Flexural strength decreases after the incorporation of the 10% fiber content for untreated and one-day fiber dissolution condition. The drop in the flexural strength can be attributed to the low level of fiber loading, which result in defect in the fabricated green composite. So random orientations of the fiber, curling of the fiber, poor fiber matrix interactions may also be the other reason for this drop in strength. There is however, a slight increment in the textural strength of the fiber dissolution condition of up to 5 days, and beyond it is increases further. Now, these are some result, computational result through the prospect theory based approach, which we have find out. So, in accordance with the primary investigation carried out through the mathematical formulation, the following material alternative, the ranking of the following material alternatives are basically having screened for further investigations. These are the polarizations of the screen out material matrix. So identifications of the optimal test conditions and composites and composition of the composite have been accomplished with the TODM method, that is Tomada di Decisio Interactive Multi-Criteria method. The decision maker consider the tensile and textural properties obtained during experimentation of the fabricated composite specimen as the criteria and different composition of the composite specimen as the candidate material. In the subsequent step, Shannon entropy method have been used to arrive the weight associated with the considered criterion. The calculated weight for are different. Calculated weight are also mentioned. That is for criteria 1 weight is 2.2304. For criteria 2 weight is 0.1921. For criteria 3 weight is 1933. For criteria 4 weight is 1902. For criteria 5 weight is 0.1940. As observed from the weight, the tensile modulus play a critical role in evolution of the optimal composition. The obtained weights are employed to obtain the relative weight. In the successive step, the overall dominance score and hence the prospect values of the material alternative, which are basically shown shown in these tables. That is the test as well as validation and simultaneously sensitivity analysis are carried out. So the depict result will show the overall dominance score obtained for each of the material alternative after applications of the TODM method. The following ranking alternative have been revealed. That is A5 greater than A6, greater than A2, greater than A4, greater than A3, greater than A1. It can be observed that PGA B530, that is PGA reinforced green composite with 30% fiber, and the 5 days of the fiber treatment with sodium bicarbonate turn out to be the best optimal composition of green composite material. Now, what about the testing and validation? So validation of the obtained result as well as the accuracy of the adapted decision making process can be done by employing a sensitivity analysis tool as by solving this past case study. So the sensitivity analysis can also be carried out for adapting certain changes in the primary model. In the present work, the sensitivity analysis has been carried out by changing the values of attenuation factor, that is theta, and by the weight exchange method. The decision maker physiological psychological behavior are taken into consider during the decision making, and they make huge effort in the decision making factors which basically consider or may be reflected in the attenuation factors, and therefore sensitivity analysis with different attenuation factors may also be carried out. Now, by the result of the sensitivity analysis, it is observed that the impact of the weight exchange method on the ranking result obtained using overall dominance score had been adjusted. A total of 90 set of criteria weight were considered for carrying out the test, which basically depicts 20 different tests that have been carried out to justify the reliability, robustness, validation of the obtained result as well as ranking. So the ranking result obtained using different set of criteria weight on the basis of overall dominance scores have been depicted in this figure, that is in figure 16. You able to see the majority of this test is 16 tests following ranking order, each A5 greater than A6, greater than A2, greater than A4, greater than A3, greater than A1. Therefore, the sensitivity analysis through the weight exchange model also reveals A5 to the best material alternative and A1 is the worst candidate material. Each sensitivity test also accompanied with the Spearman rank correlation coefficient between the original ranking and the ranking obtained for each test. Most of the tests have also been a high and acceptable range of all these problems, which what
Recording in
adjusted and
progress.
considerably their Spearman rank position coefficient will find out 0.87, that is there about good combination or acceptance of the result. Now, what are the outcome? So next, what are the outcome from basically considered as consider as the material sensitivity, that is the present prospectively based ODM methods approach had been adjusted for its true ODM approach. A stronger correlation have been revealed between the obtained ranking result. The weight extent method also corroborate the ranking result. Therefore, the propositions of the dedicated decision-making approach in the form of ODM aids in addressing the challenge of agro-waste management in agricultural sector, and hence aid in achieving sustainable global economy, and hence is one of the path to realize the dream of these objectives. Next case study is consider the performance analysis of spring material for electric vehicles. Nowadays, the electric vehicles is a popular tool have emerged. Hello. Hello, sir. Hello, sir. Am I audible to you, sir?
Sir, you are audible. It's okay.
Okay. So how much time I'll get more?
You have 20 minutes. You have.
Okay. I try to finish. Okay, sir. So these case studies will basically analysis the performance of the leaf spring, which is widely used in the electric vehicles. Nowadays, electric vehicles have emerged as one of the viable and promising solutions that aid in achieving the goal of the sustainable development. Their uses have a curtail of a detrimental effect for producing the environment by employability of different automobile industry. The operating of electric vehicle is lower in comparison to the different types of vehicles, that is fuel vehicles, that is diesel or petrol engine. So electric vehicle have high energy efficiency, but efforts are still being made to further enhance the same. The effort have been directed mainly to minimize the energy losses associated with the electric motor, electric device, battery charging, discharging, cabin ventilation, air drag, friction. Tribological solutions are being put forth in order to take care of the losses emerging from the friction. The important tribological component in the electric vehicle has been classified as follows: that is wheel bearing, transmission screening, safety device, kinetic energy recovery system, constant velocity joint, and suspension system. So from this concept, it is clear that suspension systems is very important in case of electric vehicles. So driving the quality of electric vehicle is dependent significantly on the suspension system. The automobile chassis is mounted on the axle through spring. The springs are employed in order to isolate the vehicular body from the road shock that steam out from swaying, rolling, pitching, or bouncing. As a result of the road shock, passenger experience an uncomfortable ride. Furthermore, these also result in additional stress within the frame and the body of the automobile. All these tendencies are minimized through the employability of the suspension system. So leaf spring is used vehicle to protect the vehicular body as well as passenger from the aforesaid unwanted tendency. So leaf spring should be designed using appropriate material in such a way that it is capable of storing maximum energy and release its stored energy very slowly. Therefore, however, a number of material for a leaf spring in an automobile is taken into consideration. The selection of suitable leaf spring material is critical to maintaining the vehicular safety. Design and manufacturing of the leaf spring with suitable material are very critical to ensure the comfort of the vehicular passenger as well as their safety. However, the selection of suitable material is itself as a onerous task, as the process involves the selections of the best material that meet both the technical and economic requirement. Therefore, the selection is to be made under tangible and non-tangible criteria, which are often conflicting in nature. Multi-criteria decision-making tool provide for a systematic procedure in which the designer can select the optimal material while meeting all the desired requirements. So numerous literature on the application of MCDM tool to material selections in the domains of automotive sectors is available, and already that is in literature. So new selection methodology is proposed in different scientists, which is also available from the literature, within which that is additive multiplicative ratio analysis will also take care of the significant influence of weight distributions of the criteria, as well as addition or deletion of the material alternative on the ranking result. Moreover, it is also weigh the conformity conformity phenomena, which is widely applicable over here. So AMR methods is widely applicable because it also does a way of zero deviation and prevalent amongst the extension of MCDM tool. 2DM method on the other hand take into consider the psychological behavior of the decision maker towards risks, which one of the questionable or essential aspect of the decision making process. The ranking obtained using both the methods are integrated, adapting the synchronizing or hybridization method with aggregate the multiple viewpoint to deduce the final ranking result. The combination of the present investigations are basically summarize basically the below things. The few so these are the decision making that is basically the decision matrix of the material selection for automated leaf spring. So this decision matrix basically used in the process. So in this step, the proposed decision-making framework, the criteria and the suitable material alternative for leaf spring are identified. An exhaustive literature survey has been carried out to identify the suitable material alternative. They are available for fabrication of leaf spring, the release of the potential energy stored in the leaf spring, as well as the deflection smooth out the vibration gradually and thereby provides a comfortable ride. Hence, increase in energy storage capacity of the leaf spring will ensure its function as a suspension system. The amount of energy that can be stored by the leaf spring per unit volume can obtain by using a specific strain energy equation, that is S is equal to sigma square by 2E. So specific strain energy is an important parameter for selecting this material. Simultaneously, the S can be written in another ways, that is S is equal to sigma square by twice rho E, where sigma is the maximum allowable stress and rho is the density of the material and E is the elastic modulus. So considering the dominant loading on the leaf spring is of vertical characters. So this equation, that is S equal to sigma square divided by twice rho E, a material with maximum strength and low values of ion modulus and density will be the most suitable for the leaf spring. Further, the impact toughness should also be high to prevent galvanic corrosion if the occurs due to the sudden impact. So, owing to the importance of the leaf spring in passenger safety as well as the vehicular body, attempts have also been made in the research community to synchronize their effort towards modeling, design optimization, design analysis for leaf spring with different material of construction. A parabolic leaf spring has been designed to replace the semi-elliptical steel leaf spring. A comparative analysis of the stress distribution was also carried out. So better performance of the parabolic leaf spring was revealed in comparison to the semi-elliptical leaf spring. A design analysis with newly proposed composite material for leaf spring was also carried out. So composite material constituted of 90% glass fiber reinforced polymer and 10% silicon carbide. Most encouraging properties of the fabricated glass fiber reinforced plastic composite were revealed. A composite-based monoliths was designed and manufactured to replace the existing leaf spring system. Three different material configurations was considered: glass epoxy, glass and carbon epoxy, glass and hybrid epoxy, biaxial glass carbon hybrid epoxy was also taken. So there are about 15 material combinations are taken into account of the present investigation, and then then the normalizations have also been carried out to make, and then criteria weight are also finding out. Then AMR approach, how it is implemented in this state. Basically, the priority weight of these criteria are evaluated using Shannon entropy weights. The calculus that has been adapted to obtain the criteria weight has been determined, that is well established. The AMR approach is implemented next to obtain the material rank for the case under consideration. The values of lambda is taken to be 0.5. Within the AMR approach, the values of lambda may be taken as a constant. It values greatly dependent upon the influencing parameters. Within the AMR approach, the summation of the weight compatible sequence as well as the exponentially weighted comparability. So the derived values have been depicted consequently. So that this material alternative as well as corresponding criteria weights that is also are mentioned in this table, and it can be clearly seen that in accordance with the AMR approach, the following ranking order has been evaluated, that is M11 greater than M9, greater than M3, greater than M2, greater than M7, greater than M6, greater than M4, greater than M12, and lastly the M13. So E-glass fiber was found in the most suitable materials. In the last step, the TODM approach is next employed to reduce the material ranking. Which is employed to reduce the material ranking, the overall dominance score, and the final ranking of the material alternative have been depicted in this table. The ranking has been established for theta equal to 1. So the for TODM, it is also able to found M11 is the best suited material. And now the Schuchler method is employed to next to integrate the rank result and obtain the final rank order, and hence the base material alternative for listing may be evaluated. The method was implemented via Freud-Horsell algorithm, which is basically a very important algorithm in decision making for sensitivity analysis purpose. So these are few ranking orders which is also mentioned over there. Now test and validations may also be conducted. So the robustness and validity of the obtained ranking result through the present decision-making approach, which basically hybridize AMR as well as TODM approach. The ranking obtained are judged for their robustness using the sensitivity analysis approach. This has been accompanied by changing the values of the attenuation factor, that is theta, and changing the values of the balancing parameters and the weight exchange method. The validations of the rank result has been done through the application of the presented decision-making framework to other past case studies of material selection and comparing the outcome. Spearman rank coalition coefficient has been used to compare the obtained result. Now, sensitivity analysis has been carried out. So, different values of attenuation factors has been considered to depict the impact of the psychological behavior of the decision maker towards risk. So following values of theta have been considered to carry out the sensitivity analysis, that is 0.1, 1, 2, 3, 5, and 10. The values have been obtained keeping values lambda equal to 0.5, and result obtained have been depicted in this table. It can be observed that the ranking result remains the consistent for lower values of attenuation factor, that is 0.1, 1, 2, 3, and certain variations are observed for higher values of attenuation factor. These depict the clear influence of the risk appetite of the decision makers on decision making result. However, in all case of attenuation factor, material alternative continues to be the best ranked materials. Now, the sensitivity analysis by changing the values of lambda. So different values of the balancing factor lambda, this may be taken as a constant, which is basically depend on different parameters, which having a great influence on the mathematical approach have been considered to investigate the effect of the ranking result. Following values of lambda have been considered, that is 0.1, 0.2, 0.3, 0.6, 0.8, and carry out a sensitivity analysis with respect to lambda. The result have been obtained for theta equal to 1. The ranking result have been shown in these figures. From the depiction, it is already found that the overall ranking efficiency is very good. And now, sensitivity analysis as well as weight exchange method has been carried out. Not only that, it is also carried out for past case study, that is material selection problem for gear material selection problem, and the result obtained is quite satisfactory in accordance with the other methods. So what are the outcomes? What are the outcomes from this? So the present investigation integrated the decision-making approach based on the prospect theory has been proposed to do away with the challenging of varied ranking result with employability of different decision-making tools. The rankings are established using executed multi-stative rule and to ODM approach based on the prospect theory. The ranking result are then integrated using different methods. The proposed approach have been employed to evaluate performance of the available material candidates for automobile lift swing to be employed in electric vehicle. The evaluation has been done for a total of 15 real alternative as a identified from the literary survey under the influence of 7 conflicting criteria. The outcome of the present study can be summarized below. The following ranking order has been revealed by employing the MR approach that is mentioned over here, and the podium approach also revealed some ranking. The final ranking result obtained by using Schuchel methods is follows, and egress final composite has been the base alternative materials. So the reliability of the result obtained has been judged using the sensitivity analysis approach. The sensitivity analysis result revealed that ranking result remain be consistent for lower values of attenuation factor, that is theta equal to 0.1123, and certain variations are observed for higher values of attenuation factor. This depicts the clear influence of risk appetite of the decision makers of the ranking result. However, in all cases of the attenuation factor, material alternative content to be the best ranked material. On the impact of the balancing factors lambda, it is apparent that the ranking results are stable with different values of balancing factor, and hence this is an less effective on the overall outcome. The validations of the result also judged by employing the proposed decision-making approach to other material selection problems, and the results were found in a good agreement with those obtained by the past researcher to the higher values of sphere rank correlation coefficient. So the proposed approach not only gives the considerations of the risk appetite of the decision maker, but also take care of the significant influence of the weight distribution of the criteria, as well as the addition or deletions of the material alternative on the ranking result. It always also does away the phenomena as the anti-algorithmic by zero or deviation by zero prevalent among the existing multi-criteria decision-making approach. The challenge associated with the different ranking, with the different MCDM result is also addressed through the proposed decision-making framework. So these are the another case studies. I'll not discuss elaborately. This is basically the performance of evaluated vegetable oil as a heat transfer fluid for solar application. So thank you. Thank you, the organizer, for giving me the opportunity to share few information with you, and I request you if you have any queries, so we may discuss. Thank you, sir.
Thank you, Dr. Mehti, for your insightful presentation. Now we have some time for questions.
Yes, sir. Myself, HN Singh.
Yes, sir.
Yes, sir.
My query is, sir, from this lecture, I have understood that each material is specialized and distinct as the professors of the maths department here. And a student should be very careful to make decision to select the field of work. Along with this, for sustainable technology selection, one cannot be generous because each material have a different value on various parameters. Sir, my query is ki whatever the word green is selected, it is random or there is any history behind it?
Actually, green material selections means this is basically less effect having environment. We have select the material in such a way that is basically, we are talking about the green material selection means we have manufactured a composite material in our laboratory. This is basically a wastage material. and we have recycled it by following well-established few technologies, and then we have processed it. And this material having less impact on environment. That's why we have added this concept like green.
The
material.
green word, out of all 7 colors, green has it is more I think in resonance with the environment.
Actually, sir, actually, green concept is basically greens means greens technologies means this technology having less effect on environment, less effect of environment, basically.
Right, right. Means the green word is very close to the environmental
Exactly,
resonance,
sir.
we can say.
Yes, sir, yes.
We stay with the environment. Means the environment behaves like a green property.
Yes, yes,
But not also green, but also sustainability
Right.
Exactly.
is also very important parameter in these during these days. Everyone
Yes,
is
sir.
talking about the sustainability, sustainable models, sustainable technology, sustainable methodologies, and so on.
Yes, sir. Yes.
Yes. Thank you,
Any
sir.
other questions from the participants?
Sir, one more query.
Yes, sir.
In alternatives graph, we have seen that for alternative A4 and A5,
Yes.
the graph is coming down, the sensitivity is down. Any physical significance of that for different value of attenuation factor? All the curves are coming down.
Actually, sensitivity analysis, sir, basic objective of sensitivity analysis is that how much sensitive to the
Particular alternative.
how much sensitive of the present model with in compliance with some other parameters. Because what will happen, most of the MCDM tools are very sensitive in nature. If you change the material parameters, their ranking may be changed wide in nature. But in practical situations, what should happen? A tool, when it is used for a particular, suppose we are applying the 2DM method for selection of a material for a particular case. So 2DM will provide you a base material. Then when you solve through AMR method, then they will give you the same result. It is expected. Otherwise, the technique is not robust at all. But few cases, what will happen when you solve by using other method, the ranking is different. So it is quite useless. So you need to make a sensitivity analysis. How much sensitive the present model in compliance with some other parameters. Less sensitive means it having a great value. So we are expecting the MCDM tool should be less sensitive. Less sensitive means it is highly accepted. So sensitivity analysis, there are several techniques are available. The sensitivity analysis will be conducted by changing criteria weight, by changing attenuation factor, by changing different constant, by changing by changing method of criteria weight, evaluation criteria weight, by changing some different factors are there. Okay. So any one or two factors you may take in